number 6, and then we'll look at 2 problems also from the homework. Okay, so if you're writing a series in sigma notation, the first thing is to find the formula. The second thing would be to find the number of terms. And that would be the number that goes on the top of the sigma. Ethan, I didn't look at your worksheet. I'll come back.
You did?
I didn't.
Oh.
I need to still. So finding the formula, is this arithmetic or geometric? Arithmetic, because you're subtracting 3. So the first thing that we need to do is get that formula, which is taking the first term, the n minus 1 times negative 3. So Isa, your formula says?
an equals 10 plus n minus 1 times,
I haven't got that part. What do you have for your formula?
the final one is an equals negative 3n plus 13.
There we go. So that's the formula part that goes next to the sigma. The next thing we need to do is get the number of terms so that we know that value on the top. And to find the number of terms, you just take the last number, set it equal to the formula that you just found. So if we subtract 13, we have a negative 63. How about negative 66? And is it the number of terms would be?
Oh, I was just about to get that, then I didn't put it in my calculator. It's 22.
Thanks, Matt. So you find the formula, you find the number of terms, and then we just need to write it in sigma notation. So we have the E, the sigma. In most cases, when you're writing it, it's going to start with n equals 1. I'd say 95% of the time when you're writing the problem, you should start with n equals 1 because you're given the first term. You plug in a 1 to get that first term.
Why would you do any other number?
You'll see in your homework today the reason why you would do that. Because if it's a neither problem, and it doesn't necessarily have to start with n equals 1. You'll see.
So most of them are n equals 1.
Most of them, 95%. The next thing you want to do is plug in then the number of terms, which is 22. That goes to the top. And then the formula is the negative 3n plus 13. So finding the number of terms, that's the value on the top of the problem. Next to it would be the formula. Questions? Okay, so if you look at the next problem underneath, I guess number 6, the next set of problems. We did 5 together on Monday, and this one says evaluate. And evaluate usually means find the total, get it down to a number. In this case, because it's the sigma means the sum of. So we need to find the sum of the terms that you have in the problem. The one on number 5 was an arithmetic sequence. What type of sequence is given in number 6? Is it arithmetic, is it geometric, or is it in neither problem? Is it? Does anybody know why it's not geometric? It looks like it should be, but there's a reason why it's not. Isabella? It also has a 2n. So if that 2n wasn't there, then it would be considered a geometric. So geometric sequences usually are, I have an example written right above, but usually there's a number, there's that r to the n minus 1 or just to the n, but the n is just the exponent when it's geometric. If the n isn't the exponent, then it's no longer geometric because it's serving both. So you're multiplying by an n, but you also have the power. This one is neither. So it's not geometric, it's also not arithmetic. It's just a neither problem. When your sequence or your series is neither, then I can't use the formula for an arithmetic. We can't use the formula for a geometric because there really isn't one that exists when it's a neither case. So in that case, then you need to calculate all of the terms and take all those terms and add those together. However, this problem at the bottom doesn't start with the first term. And it's asking you to start with the third term. So whatever value is underneath the e, that's the number that you plug in to find the values in the sequence. And it doesn't always have to be a 1. There are times where they just happen to make it start at a different value. And you'll see today like a sequence that actually does start at a different number so you can see what it will look like. So you're starting with 3 and you're plugging a 3 in and working your way all the way up to 8. So if you plug a 3 in, negative 1 cubed, and then 2 times 3 becomes?
Negative 6.
Negative 1 to the 4th, and 2 times 4 is?
16, or negative 16.
What's 2 times 4?
Wait, should I do this one? Why is it 2 times 4?
Because you plug in a 4
What value?
for n.
Oh, do you know?
This is in your notes, page 12. Yeah.
Any 3. Oh, okay.
So evaluate means you need to find all of the numbers. So you need to calculate all of them, not just the first value. So it starts with n equals 3. The top number tells you where to stop. So it's just not the first number or the last number, it's all the numbers in between.
Okay. Sorry, what's 2 times 4?
8, and it's a positive 8 because negative 1 to the 4th is positive. When you plug a 5 in, Sam, and then have the 1 to the negative 5th power, you get?
1 and then 12. 12
What's 2 times 5?
10.
10. And then negative 1 to the 5th power is?
That should be a 7.
Negative 10.
Thanks. I'm trying to work ahead here. So that's a negative 10. And then when you plug in a 6, you have negative 1 to the 6th power. 2 times 6 is 12. Negative 1 to the 6th power makes it a positive 12. Plugging in a 7, 2 times 7 is 14. Negative 1 to the 7th is negative, so it's negative 14. And then you stop by plugging in an 8. So that's the 16 that Sam was giving me, and it's a positive 16. So again, the reason you have to calculate all of these is because it's not arithmetic, it's not geometric. There is no way to find the sum without calculating all of the numbers and adding them together. That makes it a series and not a sequence. So the series is finding the sum of the values in the sequence. There's not a special pattern that you can follow to do that besides calculating all of them. Right?
So whenever n equals is the value you start with?
Yep, and the top number is the number you end with. Exactly. So whatever n is equal to is your starting point, the number on the top is the stopping point. So there's not necessarily 8 terms if we start at 3 and we work our way up to 8. So that number at the bottom is where you begin, the number at the top is where you end. So after you calculate all of them, these are the terms in this series, starting at 3, going up to 8, and plugging the numbers in to get those values. You add them all together, because that's what the sigma means, the sum of the terms. Virginia, if we add all those numbers together, what do you get? You get 6. So the sum is equal to 6. Questions? So again, because it's not arithmetic or geometric, and it also doesn't begin with 1, it starts at 3, you're working through the problem a little differently. There's not a formula to plug in. Instead, you're just using the sigma and the equation after it and plugging in the n equals 3 all the way up to 8. Any questions? So if you look at your homework sheet, just looking at number 6 and 8. So number 6, again, write it in sigma notation, just like the one we did. So we're going to try and write this one in sigma notation. We have 5, 10, 20, 30, 40, or 5, 10, 20, 40, all the way up to 20,480. So the first question, arithmetic or geometric? Is this arithmetic or geometric? Arithmetic, are you sure? Ethan, what do you think?
Geometric.
Why do you say geometric?
Because it doesn't go up or down by the same values.
Exactly. So it doesn't add, you're not adding 5 every time. You're adding 5 and then you're adding 10 and then you're adding 20. So Ethan, if it's geometric, what are you multiplying by?
2.
2. Yeah, you're multiplying by 2. So once you know it's geometric, the second step would be to find the formula. Ethan, do you know what the formula looks like? What's the first term?
2, 5,
5, and then 2,
Yeah.
n minus 1. So that's the formula. So now we have the first part done. We knew it was geometric. We use a geometric formula. So when we write our sigma, the formula goes right next to the sigma. Because we have just a standard geometric sequence, it starts at 1. And then we need to know the number that goes on top. How do we find the number that goes on the top of the sigma? David? So you take the 20,480, set that equal to the formula, and then we need to solve this. How do you solve it when it's a geometric formula? Maddie?
Take out the 5.
Yeah. So divide by 5, multiply by 1/5, but we want to get the exponent by itself. Do you know what that equals?
4,096.
So now the exponent is by itself. What do you do next then,
I
Maddie?
just kind of did guess.
So she used guess and check, David. We could replace the exponent form with its matching log form. And that would be log base 2, 40,096, and that's equal to n minus 1. Guess and check also works. It'll get you there. Isabella.
I don't need to be 2 up 12 equals 2 up n minus 1.
So you said 12. So then the number of terms is 13. Awesome. So 2 to the 12th power would be equal to n minus 1. So that means the number of terms would be 13, and that's how you get the number on the top. Any questions with writing geometric formula with sigma notation? So then if you look at the last problem, number 8, kind of looking at number 7 and number 8, which one of those is arithmetic between 7 and 8? Is that?
Is 7?
7 is arithmetic, so number 8 is?
Geometric.
Geometric, and it is geometric. It's just a number to a power. If there was like an n next to it, like the one we just did in the packet, then it would not be geometric. So this one is geometric. You have that 1/2 to the power of k, and it's okay that it's not an n. It's allowed to be a k. It could be a t. It could be any kind of variable, really. So how would you find the first value? So if it's geometric, the sum is to take the first term minus the last term times r, and then divide that by 1 minus r. That's the formula. And if it's a geometric sequence, you're allowed to use the formula. But what's really the first term? Like, how are you finding the first term in this sequence? What does it begin with? Tyler?
2.
Yeah, it begins with 2. So this first term in this sequence, it really isn't a sub 1 because this sequence starts with 2. So whatever's on the bottom is where your sequence starts or your series starts. So we're really skipping the first term. Our first term is actually a sub 2 because that's where this one begins at the bottom underneath. So if we want to find that, we'll take 1/2 squared. Tyler, do you know what 1/2 squared is? 1/4. The last term is whatever's on the top, and that is a 7. So to find the last one, you're plugging in a 7. So then we have 1/2 to the 7th power, which is, I think, 1 over 128. Is that right? Yeah. So your first term actually isn't a sub 1 because this one isn't starting at a sub 1. It's starting at 2. So whatever number's on the bottom is where you start. Whatever number's on the top is where you're stopping. And then you have the 1/4 minus the 1 over 128 times the r, which is 1/2. And then you're dividing that by 1 minus 1/2. Sorry, let me move my page over. So you can have it as a decimal, you can keep it as a fraction. I think the fraction is 63 over 128. The decimal is that 0.49. couple, I kept my decimal exact, so you have that whole decimal to look at. Any questions? So I have a worksheet that you'll have the remainder of the class to work on, but I want to show you how we can get a sequence or a series to start at a different number underneath. So I wanted you to see what that looks like. So I'm going to start a problem with you. Again, you have the solutions to this worksheet.
I was like half asleep.
So when you get your worksheet, if you flip it to the back four problems ask you to write it in sigma notation. Anybody not get one? Give an extra. So looking at number 10, the directions say to write it in sigma notation. Got to show some work here. Number 10 says 4 cubed, 5 cubed, 6 cubed, 7 cubed, all the way up to 12 cubed. Is it arithmetic or geometric? Sam?
Arithmetic.
Why?
Because you're just adding one.
You are adding 1, but if you calculate 4 cubed, what is 4 cubed? 64. 5 cubed is 125. So you're not technically adding 1.
What are you multiplying by?
It's neither. So this is a neither problem because you have 4 cubed, which is 64, 5 cubed is 125, 6 cubed is 216. There's really not anything you're multiplying by or adding by. They're just numbers that are cubed. So this is a neither problem. It's not arithmetic, it's not geometric. I mean, yes, you're adding 1 to get to the next value, but really you're not because that number is 4 cubed, so you're not really adding 1. So this is neither. When it's neither, you still need to write a formula. We still have to find out what goes next to the sigma. And Sarah, if it's like that 4 cubed, 5 cubed, 6 cubed, 7 cubed, all the way up to 12 cubed, what do you think the formula would be?
N plus 3
Okay, so she said from where it is, she would say n plus 3 cubed. Anybody else?
Would it be just n cubed and then n equals 4?
So we could just make it n cubed because it's a number cubed, and that number is just going up by 1, as Sam said.
Wait, but the initial.
But then your initial value could start at 4. And that's how you get that bottom number to change. Because I'm going to start by using the 4 because that's what my first term says. So Sarah, you're not wrong. You could be totally correct. And that could be a different series you would write. And you would start yours with 1. What would the top number start with if we started with n equals 4? Or stop with, I guess. Is that?
12.
Yeah, it'd just be a 12. So that would be how the number on the bottom and the top of the sigma change. They change because this is starting with a 4, so that means my n would start with a 4 instead of starting with a 1. Because now I have 4 cubed, and then I have 5 cubed, and then I'd end with 12 cubed, exactly like the series has. So number 11 is very similar to that. So when you're writing your formula, it doesn't always have to start with n equals 1 when it's not arithmetic or geometric. If it's a neither option, that's when it's going to start with a different value. Questions? So the rest of the period, about 10-ish minutes, is yours to get some work done. Is that
Is that all the work we need to show?
for that one? Yeah.